Okay, good afternoon. How's the audio and the connection? Okay, great. um, so let's look at the topics for today. The first thing is individual Skype or Zoom meeting. So if you need to talk to me individually, not via email, but through a live chat, not on YouTube, we can schedule a half an hour to an hour Skype meeting or Zoom meeting. So send me a request, and then I can set it up. So we can find a time that we can all talk. So this is an individual one. So it's not going to be a chat room where you can just listen or you can type in your questions. Understand? So if you have any concern about your coursework, the assignments, just set up a request, or I can give you a link for the meeting. Okay. You can do this on a cell phone too, because I think the Zoom and the Skype they have apps for Android and Windows as well as Apple. So this is pretty convenient, pretty common. There's no really a charge to it, I believe. Okay, as long as I know, there shouldn't be any cost associated, right? Okay. So today we'll continue our discussion on D4. Then we'll talk about D5. Then we'll talk about the midterm exam schedule. All right. Um, Hold on a second. I think I just got disconnected. Oh, okay. The connection is back. All right. So let's look at the. This is D4. So we'll talk about the state machine design. So this is example we went over in class last time. So let's revisit that first. And then we're going to look at if you want to slow down the state machines, how do you change the behavior? So let me see. We have many Abdullah Gandhi, Ibrahim Corbin. It's William Mendes here. William Muhammad Kaudi. Yeah, Muhammad Kaudi. William. Oh, yes, Muhammad Kaudi. I see you. Christian Van. William and JC. All right, so it's finished. We're going to start the simulation. Okay. Yes, Muhammad, I got you. So this is our command. I'm just going to copy and paste everything and run everything at once because we have done this already. There's no need to wait. Nothing. Simulate. Start simulation. One second. Okay. So you can see this is the behavior. So what we did was we first disabled the clock and activate the reset. That, and then we activate the clock but disable the reset. And then you see the class start. What do you mean the resolution? The resolution is determined by YouTube. So if you go to the live stream, I think you can turn on the highest resolution. By default, they give you probably not even HD as a default. So you can turn on to HD or Super HD, then you can see a high quality image. Okay. So this is the behavior of the state machine. You see that it goes through the states, depends on the X. It goes through 0001, then 10, then 00. Okay? If you look at the speed of this state machine, it is running at the same speed as the clock. Okay? If you do this on the board, you're not going to see anything. The reason is the board is 50 megahertz and it's too fast. Okay? So what we need to do for this class, assignment number D4, this is no good because you cannot run the traffic light at 50 megahertz. You have to slow it down. So the technique we developed was not to slow down the clock. Instead, you slow down how often your state machine responds to your input. Okay? So for D3, we'll talk about X and Y values. From D3, you develop something called X value, something called Y value. All right? Yes, Ibrahim, I got you. Thank you. So the X value is how many states you want to transition every time you respond to input. And Y value is how often do you respond. Okay. So for yes, Douglas, I get you. Thank you. So for Y value, you need to make it. Remember, this is not something you can get it for free. You have to make it every 1 second. And Y value is 20 nanoseconds. Okay. So the 20 nanoseconds is easy. It's one clock. But the Y value is how many clock do you need for 1 second? Yes, brilliant. Thank you. Is JC here? I guess not. So if you look at this, this means that your state machines will change states every 1 second. Each time you change state machine, you can only change it for 20 nanoseconds. And 20 nanoseconds is equal to one clock cycle. So effectively, your state machine is going to run at 1 hertz. But you didn't change the clock. That's not the assignment for. You cannot change the clock. The clock is determined by the board. The board gives you 50 megahertz, then you need to run at 50 megahertz. Understand? So any question about this concept? Changing the clock is not good. It's not acceptable. You want to. No, midterm is not this Thursday. We'll talk about the midterm schedules. Okay. Your job is not to change the clock. Your job is to change how often you respond to the input. Okay. You keep the same clock. So that means when you create your state machine, you need to have not only three processes. Process number one, state transitions. Okay. Process number two, mixed state evaluations. Process number three, state outputs. So if you run 1, 2, 3 as is, you are going to go through all the states. You are going to go through all the state at the speed of the input clock, which is 50 megahertz. But if you add process number four, which which generate X value. Process number 5, you generate Y value. Then process number 1, if X equal to 1, then you change the state. So that means you can only change state every 20 nanoseconds. But when do you get these 20 nanoseconds? You get these 20 nanoseconds every 1 second. So effectively, you're changing in 1 second. Understand? So this is the method we use. And this is the method we use in industry as well. Okay. So for D4, you need to have 5 different processes in your code. You cannot have only 3. It has to be 5. 1 for each task. Okay. All right. So what I'm going to show you is a demo to see the behavior of your statement sheet stays the same, but the speed is reduced significantly. Without running at 20 nanoseconds per state, you will run at hundreds of microseconds per state. Okay? Now, when you run the simulation at 1 second per state, it's going to take you hours to finish. Literally hours. So, when you're doing debugging, you don't want to run your simulation at every 1 second. You want to speed up your simulation. So, if your logic is correct, 1, 2, 3 always work. But if you put the X value into your code and Y value into code, your logic still stays the same, but the speed of the response or the speed of your state machine reduced significantly because you're not running at 20 nanoseconds anymore. You're running at D4 in 1 second. Right. So what I'm going to show you is a state machine just like D4, just like the D4 example, but this time is going to be slower. Okay? Remember the waveform. The waveform is 0, 0, 1, 1, 0, 0, 0, 0, 1, 1, 0. Okay? So I'm going to get out from this simulation. I'm going to start a new project. File, open project. This is a slow state machine. Okay? So this state machine has 5 processes. I'm not going to show you the code because this is very similar to what you need to do for the assignments. So let me recompile the project. Is JC here? Okay, it's finished. Good. The next thing we'll do is we are going to start the simulation. Alright, so I prepared the input already. So let me add the waveform. I change one color just to make sure that I'm running the right. Simulate, start simulation. Work, design, nanoseconds. So now I see that the state is yellow now, so I know it is the latest design. Then I'm going to apply the inputs. that he's taking his time to run through this. Imagine if you run hundreds of or millions of cycles of simulation time. It will take hours to finish. Okay? Now look at this. Look at the time. Look at the states. Look at this. When I change from state to state using my cursor to do the measurement, it is 200,000 nanoseconds. 200,000 means 200 microseconds. So you zoom in. And see each time we change states per input. So this here is my X change, my Q changes. You can see that it changes state over here from 0 to 01, but it stays there for 200,000 nanoseconds, which is 200 microseconds. And the next state change is another 200,000 nanoseconds, which is 200 microseconds. But my clock, it is still running at the same speed, which is 50 megahertz. So by playing with the X, oh, you cannot see the full screen, no problem. I want to do this. So which part you cannot see? You cannot see the bottom or you cannot see the top? So now you can see it, right? Okay. So if you zoom in here, you can see that each state is 200 nanoseconds, 200,000, 200 microseconds. So what this state machine is different from the previous one is that I have process 1, 2, 3 as is, but here I need to add the x equals 1 because I can generate xy values using process 4 and 5. My x is equal to 1, but I didn't make it 1 second. I make it 200 microseconds instead of 1 second. So that means I slow down the same machine to 200 microseconds instead of 1 second. So in D4, which is the traffic light controller, you need to make it 1 second. Okay, now this part is easy. This is part easy. But this part you need to do some math because each clock cycle is 20 nanoseconds. But you want 1 second. So you gotta figure out how many cycles do I have in 1 second. That's the logic. Okay. So any question about process 1, 2, 3, 4, 5? Okay, question about process 1, 2, 3, 4, 5. Okay. Again, 1, 2, 3 determines the state transitions. Where do you want to go? 4 and 5 determines how fast or how slow you want to respond. Okay. Yes. No, you don't have to use those names. Those names are for the example only. For D4, you need to use different names because you have different states. So the first thing you should do is you need to come up with a state diagram. Just like I show you in class. I prepare a state diagram. I give names for the inputs. I give names for the outputs. I give names for states. Okay. You can call it state 1, 2, 3, 4, 5 if you want. It's just a name. However, you want to make it more descriptive. So when you look at your code, it makes more sense to you. Imagine you have a code that's only XYZ. And then you say, what does XYZ mean? It doesn't mean anything. You give some meaningful names. This is very similar to you writing a C program where you define variables. all your variables is A, B, C, D, E. And look at your code, you have no idea what the code is doing. Why? Because the naming conventions or the names for the variables are told so bad, there's no way you can understand it unless you start going through the code line by line in detail and then understand what is what it doing. It's not going to be 5 states, okay? You gotta look at a state diagram and figure out how many states you need. So from your digital logic design class, you learned about creating a state diagram. So here, this is what you need to remember. It's not hard. Look at the diagram I give you in the handouts. How many seconds for green, how many seconds for yellow, and how many seconds for red. And then you can figure out how many states. Okay? All right. Any questions besides that? Any questions besides that? No questions? Okay. Let's continue. So next class. Oh yes. Yeah. You can give me the code for me. I can take a look. But look at the example I give you. You learn. It's supposed to be working. This is what I used. So when you say you have error with your code, did you use the code I give you on Neura, or you start typing in your own code? Oh yeah, it's obviously more than 2 bits. It's obviously more than 4 states. You're not going to get hundreds, but it's not going. 4 is enough. 4 is not enough. 100 is too much. Okay? So it's somewhere between these two numbers. Okay? Just look at the sequence of the lights. Then you can figure out how many states you need. Yeah, on Lua, I gave you the code. So let's continue on the new material for today. So I'm going to end the simulation and I'm going to get out. So let's look at this is the again number 4. Look at the output sequence. Red, sorry, green, 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 yellow, red, 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 yellow, then green, 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 yellow, red, 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 yellow. So this is a sequence you need to go through. And based on this diagram, you can figure out how many states you need. Okay. All right. So let's look at D5. What is D5? So D5 is going to be a little more complicated than D4. So let's look at the handout. So D5, you need to design a digital clock using ATO. So this digital clock is easy. There's only 4 digits. Okay, 4 digits. So what are the 4 digits? You have 1 digit for second. Because when we do demo, you can only film 1 second. You're not going to film split seconds. Okay, and I cannot see split seconds. Then you get 2 digits for the minutes and 1 digit for the hours. So we are going to use one hex value for seconds, two hex values for minutes, and one hex value for the hour. So the assignment is hex 3 is going to be hour, hex 1, 2, and 1 will be for the minutes, and hex 0 will be for the seconds, right? And then 5 and 4 are always off. Decimal points are always off. So you do not exercise those at all. So digital clock. So that means there are 4 digits running. Okay, so what's the big deal? It's a clock. But the big deal is seconds runs on its own with 1 second interval. That's easy. You know how many stages you need because you need to go from 0 to 9. Right? And minutes, same thing, an hour. The problem is that nothing is changing the speed of the seconds, but the seconds is affecting the minutes, and the minutes is affecting the hour. Understand? That's the tricky part. So that means when you design this code, you can't just run everything at once. You can't say I'm gonna run seconds, milliseconds, seconds, minutes, and hour at the same time. You cannot. Okay? You cannot do that. The seconds is going to affect the minutes and the hour. Okay? So that means when you look at your state machines, you need to do the following. Now we know nothing should be changing at the less than 1 second interval. So you still have process 1, 2, and 3. Okay, you have that. So this means your only transition state if x is equal to 1. You are going to transition states only if x equals 1. But this only represents the seconds. You need one more, while we cannot call a process 1, 2, 3 anymore. We're going to call it 4, 5, and 6. So this is second. This is minutes. Okay? So for seconds, you have 1, 2, 3. For minutes, you have 4, 5, 6. Okay? Since there are 2 digits of the minute, you need another set for the second digit. Again, we cannot call it 4, 5, 6 anymore. Let's call it 7, 8. So you see that they all have their own processes for these values. Why? Because seconds runs independently from the minutes. The minute runs independently, but uses the seconds to change states. Okay? And the minute digit 2 do this. Right? And then you need one more set for the hour. Okay? The X could be a counter, or it could be logic from a counter. If you look at D3 lecture, when we talk about counters, you can have the counter itself, you can have outputs based on the counter, or you can have logic output based on the counter. So the counter is always multiple bits, but the output logic based on the counter doesn't have to be multiple bit, it can be just one bit. Okay. All right. So here is going to be digit 1 plus 2. So you can see that this state machine is x only. This state machine is x state machine for the seconds. This state machine is x state machine digit 1. And this state machine is x digit state machine of seconds and digit 1 and digit 2 from the minutes. Okay. Download. It doesn't matter how many hours you need. This is just a exercise. So if you only have one digit for the hour, it only goes from 0 to 9. Okay, you cannot go beyond that. If you have two digits for the hour, it's going to go from 0 to 23. 0 to 23. Since we're doing only an exercise, it's going from 0 to 9. So for seconds, it goes from 0 to 9. For minutes, it goes from 00 to 59. And then for hours, it goes from 0 to 9. Okay. It's just exercise. You're not going to use this in your daily life. Okay? We're not building a class so that you can use it on a daily basis. We're just going to see if you can see that okay, there are multiple state machines working together. Okay? So now if you look at this whole setup here, you got one state machines, two state machines, three state machines, and four state machines interacting together. Okay? So what happened to the x and y? The x and y will be here. You still need the x and y for your code. So this is going to be 10, 11, and 12. This is 13 and 14. Okay? So you do keep the same thing. X equals to 1 clock, Y equals to millions of clocks because you want to make it 1 second. And S second state machine will work with X and Y, but minute digit 1 will work with the previous one plus this. So you can see that to do this project, you do it piece by piece. You figure out the seconds first because you're supposed to figure out the x and y logic from D4. Then if you do that, you can figure out the seconds. Once you finish the seconds, you finish the minutes on top of everything you built. You make that work, and then you do an extra step. So you're doing this piece by piece. Once you figure this out, you can see that this design is very mechanical, meaning that once you figure out this is the same machine you want to build, you build a second one. Then you build a minutes. Then you can see, wow, once I figure this out, I know exactly how to build a state machine. I can build multiple of them together in the same code. Everything is in one piece of code, but you just have more processes. There's more typing. The logic is not complicated because you know that the second goes from 0 to 9, the minutes go from 00 to 59, and the hour goes from 0 to 9. But they will not run at the same time because run everything at 1 second, then everything will start counting on its own. That's no good. You don't want that. You want to make sure that the seconds is always running. And the minutes will always increment if there's a second going from 9 to 0. Then the minutes will go. Then the second digit on the minutes will only go from 0 to 1 to 2 to 3 to 4 to 5, they go back to 0. But every time it goes up, you can see that the second changes from 9 to 0, and the minutes, digit 1 goes from 9 to 0. So these are the additional requirements for you to develop the logic. All right. So this is a multiple state machine design in HDL. Now to do this in a schematic, it's very cumbersome. The reason is you need to have logics for each digit. Then you divide the truth table for each digit. Then you figure out the equations for each flip-flop and for each digit. So if you know VHDL, this is the better way to do it. Okay? So any question about this? The 5 processes. So these are the processes you need to code. Any questions? Anybody else has questions? Yes, no? Okay. So let's talk about the midterm exam schedule. Originally, the midterm was scheduled for today, so obviously we cannot do it today. So what I'm going to do is I'm going to make it next month, Tuesday. Okay? So I'm going to set up a live section where I can answer questions live, just like today, but there won't be any demonstration. So the midterm is going to be online only, obviously. You cannot go to a classroom. And all the questions will be posted on Mueller when the exam starts. Okay? The format of the exam will be each question, that's the format. Each question will have its upload area. Okay? So if you see question number one, then you upload the answer to question number one. Upload question number two to three to four. Okay? But the catch is each question you can only upload once. Because this is exam, you cannot just say, all right, let me try this. It doesn't work. Let me do this. Okay? So this is a pretty much open book, open notes exam. You can use your computer if you want. Okay? I don't really care. But you can only upload your solution once per question. Okay? So each question will have its own upload, but each question you can only upload once. Alright. That's what we call a single attempt. Right now, for your project, you can upload a million times if you want. But for exams, you cannot do that. Alright. So what are topics? So we cover everything from D1, D2, D3, D4. You are going to code in HDL. Okay? You are going to simulate in Modelsim. So we have done 4 assignments already. So you can code HDL, you can simulate in Modelsim. So that means you need to know VHDL, you need to Modelsim inside out. waveform, whether to generate waveform or to analyze existing waveform. Okay, so you can use computer, internet, do an exam because I cannot check it for you. I cannot say, oh, please don't use internet. Right? So make sure that your computer runs and then you can run the software. You can type in your code and check the syntax in your software. That's okay. All right. Yeah, the midterm date is April 21st, which is next Tuesday. So any question about the midterm format? Let me check. Is JC here today? JC? JC? No? Oh, yes. For the code, if you are so confident about your syntax, you can use your software to check it or not. But the code that we're going to use to do in the exam is not going to be as complicated as the assignment. But the assignments, they're more complicated in your exam. I don't expect you to design D4 within 1 hour. That's not possible. Okay? But I expect you to do D1 in 1 hour. Anything else? Any question about the midterm exam? So remember, this is online only, so you can use whatever resources you have. Okay? You can use a computer, you can use the internet, but the limitation is each question you can only upload once. Once you upload it, that's it. Okay? If you feel, oh, the answer is number 5, you upload 5. Then 2 minutes later, oh, it's a 7. Sorry, this is it. So you better, make up your mind before you do any uploading. Right? Right. So next thing I want to talk about is the VGA. I sent out an announcement on Day1 last week requesting you to check if you have access to VGA. And so far, I've heard 3 of you emailed me. Okay? So at this moment, anybody that don't have access to VGA who have not emailed me, please let me know now in the chat. No, I cannot give you the solution for the assignment. Your exam is not going to be complicated as the design assignments because you don't have the time stamp. The exam is to test if you know how to do visual coding, not to see if you could design number 4, D4. Okay? I said access to VGA. No, we never give out solution for the code. If you give a solution, then you can just pass it on to somebody else. These assignments may be reused for future assignments. Yeah, we can go over the assignments on Thursday, but I'm not going to tell you here's a code, please use it. So please let me know at this point who have access, who does not have access to VGA at home. So I've heard 3 students from this class. Okay, so Christian, you're all set. What about Manny? Muhammad, yes, I understand that. Anybody else? Mahaji, you're good? Okay. Muhammad or Haji, you don't have one? Anybody else don't have one? What about Aaron? Van, Rawa, William, Abdullah Agandi, Muhammad Khaldi, Ibrahim. What about you? Okay, that's good. Yeah, I understand. You reviewed, yes. We can have a review. That's no problem. Okay, William, you do have access. That's great. What about Ibrahim, Abdullah Agandi, Muhammad Khaldi? What about Rawan? Then access to VGA at home. But if you do not have access to VGA this time, I guess this is the exception. However, for your senior year, you must have access to VGA at home because you cannot keep going to the lab because the lab will be closed. So make sure that you have the access to VGA starting starting the summer. You need to have that. And this um, I don't understand that. What do you mean by C code program? There's no C program for VHDL. We're talking about VHDL. Okay, Muhammad Khan, you don't have one? That's fine. There's no C program for midterm. It's only D1, 2, 3, 4, VHDL. No, the lab will be open, but the lab will have other classes. When we go to the semester schedule, the lab is busy at least for 6 to 8 hours a day. And people have classes in there 6 to 8 hours per day from Monday through Thursday. So how do you find time to go in there to use the monitor? Yeah. The, the project is a separate thing. Right now, what we are talking about assignments D1, 2, 3, 4, the midterm, and do you have access to VGA? The answer I want to hear is yes, you have, no, you don't. So far, some students don't. Yeah, it's okay. Again, I'm not asking you should buy a TV right now. I'm asking you, do you have access to VGA right now? For example, I have an old monitor from like probably 20 years ago, which I'm still using. Luckily, it has a VGA, so I can use it to do the assignment. I don't have to go out and buy a new TV for the VGA. But if you have a TV from yesterday, it probably doesn't have VG connection. I understand that. That's okay. But just let me know if you have VG access or not. Okay. All right. Uh, any more questions? Then earlier today, you told me you have a problem with the code. Do you still have the same issue? If you have that same problem, send me the passcode for the supports. I can take a look. And to those who have no problems with the assignment number 4, you can log off from the live. Okay? And make sure that you prepare the questions you want to ask during Thursday. During class, we can discuss more about the questions you have regarding the HDL, regarding assignment 1, 2, 3, 4. All right. So make sure that work on the assignment number 4, the traffic light control. At least you get a sequence working. If you don't get a blinking working, you still get partial credit. It's more work for the blinking. But if you do the sequencing, it's a lot of accomplishment. Okay. Okay, then you're good. You're all set. That's great. Anything else you want me to look at? Anybody? If you go on ULearn, so right now we are. I post everything. I have the example for the state machine. I have the commands. This is the one that run them every single clock. So for the assignment D4, you need to use process 4 and 5 to figure out the X and Y value so that you can slow it down. Okay? Alright. So let me ask before we leave today, any questions? Is JC here? I guess no. Okay, if you don't have any question, you can leave the line. I'm gonna terminate that in a few minutes. Okay? So spend your time, work on D4. It's uh it's very important because starting from D4, everything will be state machined. Everything.